All right, everyone. Today we'll be going over the Final Lab project, part 2. In this part, we were tasked with grabbing our previous deployment and upgrading it with 2 new modules. So today I'll be talking about the 2 new modules I implemented, what their use cases are, and then showcase how they work. All right, so we'll start with our 2 modules. So the easiest modules I thought to deploy would be a health checker. I don't know if this is the specific word. Yes, a health check system. Health checker, same thing. So this is one of the most essential types of deployment patterns in Kubernetes or distributed systems. With Kubernetes and distributed systems, you can have pods running for extended periods of time, days, months even, and sometimes they stop working. Without periodic checks to make sure they're working, you can have entire apps and deployments fail with no real explanation why. And with the modularity of Kubernetes and the design for rapid scaling up and scaling down, pods tend to be easy and quick to restart and reset, and they do solve a lot of problems. So what a health checker does is it simply checks occasionally at some set interval if a pod is running. If it is running, nothing changes. If it's not running, then it's restarted and replaced with a new one of the same type. This enables any downtime to be short and any sort of fixing processes to be automated. This also provides the benefit that simple solutions and simple problems tend to be fixed quickly, whereas more complicated ones can be more focused on if everything's not working. So here I have an example of a health checker. So as you can see here, I created an app or a pod called Random Generator. This simply just generates random numbers to keep it busy. And as you can see here in this first stage, it is working. It is up, the status is up. And then here we send a command which causes it to fail. It's a purposeful command to make it fail. And then afterwards, we check the status again, and you can see that the status is down. Now here I can get pod health, and you can see that there are 2 restarts for the random generator pod. So this is the health checker. The next pattern I implemented is a declarative deployment. So declarative deployment enables you to deploy new versions of already existing pods without taking down the service for an extended period of time. In this case, we used our random number generator again as our main pod. And here you can see we set the image to random generator 2.0, which is the 2.0 version. Nothing changes, but functionally it's the same, but it is the 2.0 version and Kubernetes thinks that. So you can see after we call get pods, you can see here that the container remains running, the pod remains running, but you can see here that another pod here is queued up, the 2.0 version of random generator, and remains on container creating. Afterwards, we get the pods once more, and you can see here that the first generation or the first iteration remains running until the second generation gets running up, and then the time is spent getting rid of random generator 1.0. Afterwards, we get the pods again, and you can see that the old version is terminated and the new one remains up. This allows us to do deployments where, for example, you want to update an app that people are currently using without causing any downtime. This would be a useful case of this. This is also can be further expanded upon to do deployments where only X amount of users get the app and the other half do not. So another example of this would be a use case for this would be the rollout undo, which lets you undo an existing push of an app that you've done. So as you can see, we run the command here, and I do the get pods a little too late, but it rolls back, and you can see the ID is different, which indicates that it is a different version of random generator. I can also further prove the rollout function by doing a rollout history, and you can see that it revised twice. And yeah, that's about the end of that. Please refer to my presentation and my document for more information.